Hi, this is Balkishan, lecturer in chemistry, Government Degree College, Siddipet. Today, our topic is Knoevenagel reaction, Knoevenagel condensation. Knoevenagel condensation is statement is conversion of aldehydes or ketones into the alpha beta unsaturated carboxylic acid in the presence of active methylene group compound. Active methylene group compound and base like pyridine or secondary amine. So this one. Okay. Now the statement of Knoevenagel reaction is that conversion of aldehyde or ketone in the presence of active methylene group compound and base, that is pyridine or secondary amines, to form alpha beta unsaturated carboxylic acid. So this is the Knoevenagel condensation or Knoevenagel reaction. In this one we want to know some information the aldehyde or ketone may or may not be contains alpha hydrogens. This is not the criteria. Here not importance of alpha hydrogens in case of aldehydes or ketones. This one point. And second one, active methylene group component. So this CH2 group is called as methylene group. CH2 group is called as methylene group, is the bivalency group. If the methylene group bonded with electron withdrawing groups, this is the electron withdrawing group. This is also electron withdrawing group. If the methylene group bonded between the electron withdrawing group, then it exhibit highest reactivity. Then this methylene group is called as active methylene group. Example for the active methylene group this one, CH2COOH and COOH. This is called as malonic acid. Malonic acid is one of the example for the active methylene group component. One more example, CH2 COOC2H5. This is called as malonic ester. One more example CH3 C double bond O, CH2 C double bond O, OC2H5. Ethyl acetoacetate. Okay. Now these three are the example for the active methylene group component. Now in this one the active methylene group acts as a nucleophile and will form carbene ion. Due to this carbene ion, it acts as a nucleophile. Okay, that's why this nucleophile attacks the aldehyde or ketone. That's aldehyde is the, ketone is the first reacting molecule, and the active methylene group is the nucleophile producing reactant. And to produce nucleophile, we require base in case of active methylene group. Active methylene group, when reacted with base only, it releases and it produces a carbene ion. That carbene ion acts as a nucleophile. That's why these two will produce a nucleophile. This nucleophile is added at aldehyde or ketone of carbonyl group. That means indirectly Knoevenagel reaction is nothing but it is the nucleophilic addition reaction followed by elimination. Okay. Now in this case a new carbon to carbon is formed in Knoevenagel condensation. Okay. And water molecule also eliminated. Okay. These are some features about the Knoevenagel condensation. And listen carefully. Conversion of aldehyde or ketone into alpha beta unsaturated carboxylic acid with active methylene group compound in the presence of base like pyridine or secondary amine is called as Knoevenagel condensation. In Knoevenagel condensation, the aldehyde or ketone may or may not be present or contains alpha hydrogens. That alpha hydrogen phenomena is not compulsory in aldehyde or ketone in Knoevenagel reaction. And what is methylene group? CH2 group is called as methylene group. And when the methylene group is bonded with two electron withdrawing groups like C double bond O, C double bond O, it exhibits highest reactivity. That's why this type of methylene group, that means the methylene group which bonded in between the electron withdrawing groups is called as active methylene group. The organic compound which contains active methylene group called as active methylene group compound. Example for the active methylene group compound, one is the malonic acid. In this malonic acid, this CH2 is the active methylene group because of it bonded with C double bond O, C double bond O group. One more example this is active methylene group. It is bonded with COR, COR. It is also electron withdrawing group. This is the ester, this is the carboxylic acid. One more, but this is also active methylene group because it bonded in between the carbonyl group, it's electron withdrawing group. This is the ester group. That's why these three are the example for the active methylene group compounds. In this reaction, active methylene group will produce a carbene ion which acts as a nucleophile in the presence of base like pyridine or secondary amine. Okay. Now this carbene ion adds to the aldehyde or ketone to form alpha beta unsaturated carboxylic acid as a final component. So this is the introduction about the Knoevenagel condensation. After this one I am taking one example That example, any example that is aliphatic aldehyde or aromatic aldehyde can be used in this reaction. Any aldehyde, any ketone. I am taking for convenient benzoaldehyde. This is the example one. Benzoaldehyde. its name is benzaldehyde. Benzaldehyde reacts with this one. This is the one of the active methylene group compound. Its name is malonic acid. Malonic acid. In the presence of base and the pyridine or secondary amine. This is the secondary amine. To form and the finally this one. CH double bond CH COH. Okay, so this is called as cinnamic acid. Cinnamic acid or alpha beta unsaturated carboxylic acid. Why? Because this is the functional group. This carbon is alpha carbon, this carbon is the beta carbon. In between alpha carbon, beta carbon, there is a double bond. That's why it is called as alpha beta unsaturated carboxylic acid. Okay, that's why benzaldehyde reacts with active methylene group, that is malonic acid, in the presence of base like secondary amine or even the pyridine. To form cinnamic acid, that is alpha beta unsaturated carboxylic acid. So this is known as Knoevenagel condensation or Knoevenagel reaction. Mechanism of this reaction. Step 1. Formation of carbene ion or nucleophile. Formation of carbene ion or nucleophile. Now this one I am writing CH, COOH and COOH, and separately I am showing one hydrogen. When in the presence of R2NH, this is the base only. This is the base. So this is the malonic acid. Reacts with this is the acid, will give H plus ion from here. This is the active methylene group only. Comparatively with this H plus ion, this hydrogen is highly reactive. That's why this hydrogen eliminated and this accepted by this, and R2 NH2 plus is removed and forms this carbene ion. This carbene ion also stabilized by resonance. That's why this is the stable one. When H plus ion here eliminated, that type of resonance is not possible. This carbene ion can be stabilized from here to here. Okay, that's why this carbene is more stable and it easily forms, then further reaction takes place. Step 2. Attack of carbene ion. Attack of carbene ion or nucleophile. Okay, this is now I am taking benzaldehyde. This structure is this one. Benzaldehyde reacted with carbene ion. So this is the carbene ion which formed in the first step. This bond shifted towards the oxygen. Oxygen gets negative charge, carbon gets positive charge. The positively charged carbon attracts the negatively charged carbene ion. That's why the carbene ion attacks this carbon. It is called as nucleophilic addition. Then, so this is the intermediate product. Benzene ring, here CH O minus. Now new bond with this one, CH, CH to CH new bond and COOH and COOH. This one. Okay. Next step is, in the presence of this one and R2 NH2 plus and it will take H plus ion. H plus ion added to this one. Then we obtain this one. CHOH and CHCOOH, COOH. This is one of the intermediate product. And step 3 and step 3, formation of product. Formation of product. That is the CH, OH and CH, COOH, COOH. This dicarboxylic acid is unstable and now this can be eliminate one CO2, minus CO2, we obtain this one. CHOH and adds this one CHH and COOH. This dicarboxylic acid converts into the monocarboxylic acid. Monocarboxylic acid. This monocarboxylic acid and by the loss of one water molecule, so this bond shifted to this side, this bond shifted to what's the OH minus H plus, eliminated as a water molecule. Eliminated as a water molecule and obtain the final product. CH, COH. This is the cinnamic acid. Cinnamic acid. Okay. Knoevenagel condensation is the best example and similar to the Perkin condensation. In Perkin condensation also, only aromatic aldehydes involved in the Perkin condensation. In this one, aromatic or aliphatic you take in. But the final product is alpha beta unsaturated carboxylic acid. In Perkin also, alpha beta unsaturated carboxylic acids are obtained. Okay, that is similar. Only thing is changing of this interacting molecule. In case of Perkin condensation, we will take the anhydride to produce carbene ion. But in case of Knoevenagel condensation, we are taking active methylene group compound like malonic acid or malonic ester or ethyl acetoacetate. Any active methylene group compound, if involved, that is called as Knoevenagel condensation. Okay, I am taking this is instead of benzaldehyde and second example. This is the example 2 only. Now example 2, I am taking CH3 and this is called as acetaldehyde. Acetaldehyde. Here we obtain and here CH3 and only phenyl group is substituting by methyl group. This is called as crotonic acid. Crotonic acid. Crotonic acid is obtained. Similar mechanism. Just to you change this phenyl group by the methyl group. Here also methyl. Here also methyl group. Here methyl group. Here methyl group. Here methyl group, here methyl group. Okay, that's why when we take benzoyl we obtain cinnamic acid. Okay, when we take acetaldehyde, we obtain protonic acid. Okay, both are the alpha beta unsaturated carboxylic acid. So this is known as Knoevenagel condensation or Knoevenagel reaction. Okay, this is completed. Now next topic only. We completed only the important topics in carbonyl compounds only. That is the important topics are these are the very important topics for your common examinations or competitive examinations. One is aldol condensation only. Aldol condensation. Second one is Cannizzaro reaction. Cannizzaro reaction. Third one is Perkin condensation. Perkin's reaction. And benzoin condensation. Benzoin reaction. Fifth one, just now we completed. Knoevenagel reaction, and one more, haloform reaction. So these are the very important reactions. After this one, these are the named reactions. Named reactions. In some competitive examinations, they may give this type of questions also. This is 2-butene only. Its name is 2-butene. This is on bosonolysis only. O3 followed by H2O2 in base media. Ozonolysis, or simply I am writing ozonolysis. Ozonolysis formed a compound. A compound is reacted with dilute NaOH, formed a B only. B on heating only, C is obtained. Here A also reacted with this one, CH2COOH and COOH in pyridine. In pyridine, D is obtained only as a final product. As a final product. What are A, B and C and D? This is the some variety question. We understand this all the reactions only. Based on these reactions, I given a conversion. 2-butene on ozonolysis, A is obtained and this A subjected to dilute NaOH, B is obtained. This B on heating converted into C. If A subjected with malonic acid in the presence of pyridine, D is obtained as a final product. What are A, B, C and D? in the given conversion. To solve this problem, I am giving some information. You remember, this is actually reaction in lower classes. That means it is in B.S.C first year class or in intermediate syllabus. Okay, always you remember ozonolysis. Ozonolysis of alkenes will form carbonyl compounds. So this is the statement. You always remember, ozonolysis of alkenes will form carbonyl compounds. So this is CH3, CH double bond CH, CH3. Ozonolysis means just to, where is the double bond? You just cut the double bond and add the oxygen in both carbons, to the both carbons. Then we obtain this one, CH3, CHO. CH3, CHO, CH3, CHO, which is called acetaldehyde. Acetaldehyde. So this is the A. In this reaction, A is the acetaldehyde. We completed it. After A is the acetaldehyde, CH3, CHO. This is the A, acetaldehyde. When it is reacted in the presence of dilute NaOH, this is nothing but this aldol condensation. Aldol condensation. I given detailed explanation in the previous video, that is aldol condensation video. In that video, acetaldehyde 2 molecules, we obtain 2 molecules. These 2 molecules condense to form this one. So this is called aldol. Aldol is the B. Its name alpha beta hydroxy butyraldehyde. Which on heating here one hydrogen, one OH eliminated as a water molecule. Then we obtain CH3, CH double bond CH, CH. So this is the CH, protonaldehyde. Okay, A is equal to acetaldehyde, B is equal to beta hydroxybutyraldehyde, C is equal to protonaldehyde. C is equal to protonaldehyde. C completed and A just now we completed A is the acetaldehyde, CH3, CHO. When it is reacted with this one this is called as active methylene group. In the presence of pyridine just I completed this reaction, which is known as Knoevenagel reaction. Knoevenagel reaction. In Knoevenagel reaction, this will be formed. Just I given, this is called as protonic acid. Okay, so this is conversion of this alkene into the different compounds. One important conversion. Okay, another type of reaction same. One more conversion it is useful in your competitive examination like PG entrances or any other competitive examinations. One more I am giving for this one, CH2 double bond CH2 double bond CH2 ozonolysis అండి. Ozonolysis obtained A అండి. A when reacted with concentrate NaOH obtain B and C. B and C. Now A if subjected with methyl magnesium bromide and hydrolysis obtain DM. D when subjected with okay, again already Knoevenagel condensation just now completed and so this is one and okay. Mari what is the explanation for this conversion andi? Already I given any alkene andi subjected to ozonolysis andi, just you cut the double bonded carbon, add the oxygens andi, then we obtain andi CH2O. This is nothing but HCH1 means formaldehyde. That is A is equal to formaldehyde. Here ethylene on ozonolysis A is obtained. Ethylene on ozonolysis formaldehyde is obtained. This formaldehyde and two molecules of formaldehyde when subjected with concentrate NaOH. Always you remember when we add concentrate NaOH to the formic acid, that means formaldehyde means absence of alpha hydrogens is involved in the Knoevenagel condensation. Knoevenagel reaction. In Knoevenagel reaction what happens and one molecule reduces into alcohol and the second molecule oxidizes into salt of carboxylic acid. That's why we obtain HCOO-Na. This is called as sodium formate. Sodium formate. This is nothing but let B. B is the sodium formate plus C and is methyl alcohol. This is the CN. Okay. A completed. A is the formaldehyde. B is the sodium formate. C is the methyl alcohol. And this reaction is the Knoevenagel reaction. Okay. And A, that is double bond OH, reacts with methyl magnesium bromide. Okay. And forms and so this is the minus, this one plus and this bond shifted to this side. O minus attracts the plus part and C plus attracts the minus part and we obtain CH3. Here CH3 added and CH2. This is the CH2O MgBr. This is called as intermediate or intermediate product. This on hydrolysis and H2O in H plus and so this is the hydrolysis and from year to year bond will be broken and obtained and ethyl alcohol. That means the D is the ethyl alcohol. D is the ethyl alcohol. These are the different conversions. Okay. Now one more conversion. One more conversion. This is also alkene andi. I am taking this alkene. This one. Same ozonolysis. Ozonolysis obtain andi. A plus B. A plus B. A B on dilute NaOH forms C andi, which on heat forms D andi. A or otherwise I am giving, this is already I2 and NaOH andi, will give C andi. Here A, I2, NaOH, no reaction. No reaction. And this one with acetic anhydride. The short formula of acetic anhydride is AC2O. In the presence of this one will give DM. What are A, B, C, D in the given conversion. Given conversion. Find the A, B, C and D. Solution. Solution. For this one only, common reaction in today class only, this ozonolysis. In ozonolysis only, in ozonolysis, I am cutting this one bond, oxygen is substituted. That's why we obtain this one, CHO plus CH3CH4. Benzene ring CHO, CH3CH4. One is the benzaldehyde and one is the benzaldehyde and other one is the acetaldehyde. Acetaldehyde. In these two only, which one A, which one B? That is the very important factor. Benzaldehyde is A or acetaldehyde is A, or B, benzaldehyde is B or acetaldehyde is B. We can find based on the given. Here, iodine plus NaOH. In the previous video, I given iodoform reaction or alloform reaction. The aldehyde or ketone which contains 3 alpha hydrogens involved in iodoform reaction. Here, in this one only, there is no alpha hydrogens. That's why I2NaOH, no reaction. A is no reaction with iodine and base. That's why A is nothing but A is the benzoyl. This is the explanation. And this acetaldehyde containing 3 alpha hydrogens. 3 alpha hydrogens are present in the acetaldehyde. That's why it can be react with iodine and NaOH to form only iodoform. So this is the Cl. Iodoform is main product. Byproducts are so many one. The main product is the iodoform. That's why I am giving, or here in some cases they may give yellow precipitate under. That's why this is the C is the yellow precipitate. C is the yellow precipitate. Now after this one, here D, A reacts with this one, CHO plus, so this is the acetic anhydride in the presence of sodium acetate. So this is nothing but, this is the Perkin condensation. Perkin's reaction. In Perkin reaction, we obtain only alpha beta unsaturated carboxylic acid. This is the cinnamic acid. Cinnamic acid. This is nothing but D. Therefore, in this conversion, A is the benzoyl, B is the acetaldehyde, C is the iodoform, D is the cinnamic acid. Conversion of A to D is Perkin condensation and B to C iodoform reaction. Okay, so this is information involved in this conversion. Okay, today with the Knoevenagel condensation, Knoevenagel reactions are completed in previous video and today video, and some of exercise based on the Knoevenagel reactions and iodoform reaction. Thank you very much.